Yeah, welcome very much to this session on importing data, which is probably one of the most fundamental sessions of all, because whenever you want to do some data science, you need some data. And whenever you want to use some data, you somehow need to import that data into R. So this session is about how you take raw data that you have collected yourself, that you've gotten from the internet, and how you take this data, import it into R, such that you can then do further analysis with this data. So the goals for today are, to summarize, first of all, to learn how to handle raw and tidy data in R. What raw and tidy data is in the first place. Secondly, we want to learn how to import data into R using the fread function from the package data table. This function can be used to import data that is stored in a particularly common file format called CSV, comma-separated values. But good news is that whenever you know how to do this, you basically learned most of what you actually need, because most other file formats that are common are much easier to handle. And thirdly, we want to quickly have a look at how to save data in R, although I can already tell you that saving data is much easier than importing data. Also, just to put the whole session content a little bit into perspective, data importing is usually part of data preparation and data processing. So it's basically part of the first step of your project work in R. Before we do some visualization data analysis, we need to import data. Usually when we import data, we then later need to prepare it. But this is going to be part of the second session. This year is about importing data, and together with preparing, as I said in the beginning, it's probably the most fundamental task in data science. Yet, I would also say it's one of the most underappreciated tasks, at least when it comes to people who are not data scientists themselves. Because it is really very difficult to do, especially if your raw data is rather messy. Therefore, it's a skill that you definitely should invest some time practicing, because without knowing how to import data, you can be the best modeler whatsoever. It won't help you because you won't get the data to be analyzed into your computer in the first place. So the main focus of this session is actually to build upon the session on project management. In the session on project management, you learned how to come up with a default directory structure for your R projects, how to set up an R project in the first place, how to use absolute relative package, etc., etc. If you haven't heard about that at all, I recommend you to have a look at this short session on project management, because here we assume that you have actually set up your project environment in the way that we have discussed in this session. Now, taking for granted that you have this directory structure, we want to learn how to import data in the CSV format. As I already said, CSV is probably the most widely used file format when it comes to data. The reason is that it's perfectly transferable across operating systems and computers, because it's basically a very simple text file, where the data that is saved in the table form, where the columns of this data are separated via commas. So you can basically move it from Windows to Mac OS, etc., without any particular problems. Downside is it's pretty bad when it comes to file compression. It's pretty bad when it comes to importing speed if you compare it to more specialized formats. But usually, for most cases, it's still a very good choice because it's so widely used and easy to transfer from one space to the other. And I think it's a very good starting point, because most example data sets will be in the CSV format. And at this point, it might also be worth reminding us of this general rule that all the results we derive in an R project must be reproducible from the raw data at any time. This has some implications for the handling of the raw data, because we must not manipulate our raw data at any cost. You should ever avoid that. This means that if you import the raw data, and by raw data I mean what you download from the internet, what you have gathered through your experiment, or maybe data that you have coded yourself. Whenever we import this data into R, we must not change it. And all the things we do to the raw data, they must be documented, and the manipulated data must be saved under a different name in a different file. So here in this session, we focus on how to get the raw data into R, how to import it, and then to get it out of R into the file system again. This basically means we are ignoring, first of all, everything that comes before, like setting up our project environment. There's a separate session for that. We are also ignoring everything that usually comes in between importing and saving data, namely the whole data preparation thing, where we turn the raw data, the data that we have obtained, into so-called tidy data, which is then the basis for further analysis and visualization and so on. So here we really focus how to get data into R and out into the file system. And basically that everything that happens before or in between will be touched upon in separate sessions. So here, again, a very short recap. This raw data, it must not be changed. However, we somehow need to change it in order to get it into a state we can work with. Therefore, workflow again, gather data, save it on your computer, import this data into R. This is what we're about to do now. Then write a script that transforms this raw data into data you can actually work with. This is the data we call tidy data. And then save this tidy data and use it for further analysis, such as visualization, modeling, etc. Here we focus on step 2, and basically the last part of step 3, namely the saving of this data. This way, we will write scripts that make our work fully reproducible and also serve as documentation of what you did. That makes it much easier for you to basically come back to your project work after a couple of weeks and to immediately understand what you've done. It also helps you to basically heal every mistake you made, because the original raw data is not touched upon. So if you make a mistake, that only affects the tidy data that you save under a different name. So you can just correct the mistake in your script, and you can still work with the original raw data and create new tidy data, which is then again fully reproducible. And here again, another slide that you might have seen in this session on setting up an R project, where we basically focus on this first step, how to set up your project environment, which you usually only do once per project. Here we focus on these 2 steps that you might iterate over time, because you import data, you do some transformation, you save it, but then you figure out, okay, you actually did the wrong transformation, so you need to import it again, do the modified transformations, and then save it again. So importing and saving data is something that you might be doing a couple of times during an R project. Another reason why it's so important to actually getting good at it. So let's start.